Let's solve the 10th problem from the list Top Interview 150 from Leetcode. The name of the problem is Jump Game 2. So this problem is a follow-up problem for the last problem we solved, which is called Jump Game 1. And the only additional requirement in this problem is that instead of returning a Boolean variable where we can say if we can reach the last index or not, we have to return the minimum number of jumps in order to reach nums of n-1, which is also the last index. Now, the way I see this problem is that we need to add some more states to the problem. The overall solution will look like very similar to what we did for the last problem, where at every index, we want to know what is the maximum reachable so far for this current index. And the way we will calculate the maximum reachable is by the same formula we used in the last problem, which is add the jump count of index to the value of current index, and whatever is the new value is our max reachable value for that current index we are standing at. Moving forward, if we want to return the minimum number of jumps, we will definitely need a variable to store jump count, and initially this will be set to 0. One more thing which we will need to store a state is that we need to know what is the boundary of the current jump. So for example, let's say we are at 2. So in this case, the max reachable for this index is the current index, which is 0, plus the nums of current index, which is 2. So that will be 2. So we can reach till 1. So if we make this jump, the boundary of this jump will be till here. We won't be able to go any further beyond this jump. So for every jump, we also need boundary index of this jump. Now, initially, when we are standing at the first index or the 0th index of the array, the jump count is set to 0 and the boundary of this jump is also set to 0. So assuming an imaginary jump which happened before this, and that jump had a boundary index of 0. So now at every index, if we want to know what is the minimum number of jumps which we will take to reach the last index, what we need to do is every time we reach the boundary index of the jump, which means while iterating on this nums array, every time the current index is equal to the boundary of the jump, which means if we are starting at index 0 and we keep going ahead, we keep calculating max reachable. And at any point, if the current index becomes equal to the boundary of the jump, which means we have reached the end of this particular jump. At that point, we will have to increase the jump count by 1 and update the next jump's boundary by whatever the max reachable we found in the previous range. So the way it will work is at every index, we need to know if this index is a boundary for my current jump. If yes, then accumulate the jump in jump count and update the boundary for my next jump with max reachable in the previous range. And finally, return the jump count. The way by which we are going to know if the current index is a boundary for my current jump or not is by checking the condition if current index equals to boundary of current jump. So given this, let's go ahead and write code for this problem. So similar to the previous problem, we will need a max reachable set to 0. We will also need a jump count variable, which will also be set to 0, and we will need a boundary of current jump, which will also initially be set to 0. Now we start iterating on the nums array, and current index starts at 0, and the index is less than nums dot length minus nums dot length, and current index plus plus. Now finally we return the jump count. Now here, first we need to find out what is the max reachable for this current index. So max reachable would be max of max reachable and current index plus nums of current index. After this, we need to know if this index is a boundary for my current jump or not. So let's check that. If current index is a boundary of current jump. If that is the case, then we need to accumulate the jump, which means we need to increase the jump count by 1. And we also need to update the boundary for the next jump. So we will update the boundary of jump by max reachable. and at any given point, eventually we will reach, current index will reach nums dot length minus 1, and at that case we want to break, because it's given that we want to return the minimum number of jumps to reach nums of n minus 1. So if we have already reached, if the current index is already nums dot length minus 1, then we don't need to do any further processing. We can also rewrite this by just decreasing the value, so we will not be iterating for the last index, and just clean up this code. And now let's try to run this code. And as you can see, all the sample test cases are passing, so I'll go ahead and try to submit this. And we get an accepted solution. So in this video, we solved the 10th problem from the top interview 150 list from Leetcode, which is called jump game 2. In the next video, we'll be solving the 11th problem from this list.